In this section, we will talk about derivatives of trigonometric functions. So here we have a list of the derivatives of trig functions. And here's a quick trig recap. So when we have tangent of x, if we're taking the derivative of just tan x, it's equal to secant squared of x. But what if tan x is involved in an expression that has also like sine, cosine, or secant or cosecant? For example, let's say our expression is tangent of x times cosecant of x all over, like, let's say secant of x, right? In that case, you would always replace tan x with sine over cosine when it's part of an expression with other trig functions. Cosecant, same thing. Every time you see cosecant and it's part of an expression that involves other trig functions, we replace it with 1 over sine. Secant is 1 over cosine. Cotangent is the reciprocal of tangent. So if tangent is sine over cosine, then cotangent is cosine over sine. And then anytime you have sine squared of x plus cos squared of x, that equals to 1. And always make sure your calculator is in radian mode, because everything we do in this class will be in radians and not in degrees. Just a quick note for this. If you have sine of x plus cosine of x, it does not equal to 1. That is not equal to 1. It's only when it's sine squared of x plus cos squared of x that is equal to 1. Let's take a look at some examples. We're given that f of x equals to cosine of x. We want to find the derivative of cos x, or f of x. So here, based on our list of trig functions, the derivative of cos x is negative sine of x, so that's easy, just negative sine of x. And then if we have f prime of 2, we have, so f prime is negative sine x, so we have negative sine of 2, that's negative 0.9093. Just, again, make sure your calculator is in radian mode. Now, f double prime of x, it means the derivative of f prime of x. Okay, so once again, f double prime of x would be the derivative of f prime of x. So if we go back and we look at our derivative of sine of x, that's equal to cos x. So if we take the derivative of f prime of x, that'll equal, so the derivative of sine is cosine, but we have a negative sign that carries down. So once again, what's happening here is we have f prime of x equals to sine of x. So if we take the derivative of f prime of x, that would be the derivative of negative sine of x. We know that the derivative of sine of x is cos x, and we have a negative sign, so it becomes a negative cos x. Now in letter D, we're taking f triple prime of x. So now we're going one step further, and we're taking the derivative of f double prime of x. So here we have the derivative of f double prime of x, which is going to be the derivative of negative cos x, because f double prime of x is negative cos x. Let's go back here. The derivative of cos x is equal to negative sine of x. Okay, so if I take the derivative of cos x, it's going to be a negative sine of x. But we also have this negative. So we have these two negatives back to back, which will turn into a positive sine of x. Okay, next we have f of x is given to us as 4x times sine x plus cos x. We want to find f prime of x and f prime of 3. Now, first thing we have to recognize is that we have a product rule, because we're multiplying one expression 4x times another one, which is sine x plus cos x. So we're going to say our first term is a and our second term is b. Now remember that it's very helpful that you write down the 4 things we need on the side. We need a and a prime, b and b prime. So a is 4x, which means a prime is 4. Remember, our rule is we take the 1, multiply that with the 4, and we subtract 1 from the exponent. So if you have 1x, you take away 1x, the x's are gone. So the derivative of 4x is just going to be 4. b is sine of x plus cos x. The derivative of sine is cos x, and the derivative of cosine is negative sine x. So that's going to be our b prime. Now we just plug this into the product rule, which is b times a prime plus a times b prime. So I have my b, which is sine of x plus cos x, times my a prime, which is 4, plus my a, which is 4x, times my b prime, which is cos x minus sine x. And then if I do f prime of 3, so plug this, replace each of the x's you see with a negative, with a 3, we're going to get negative 16.9688. Okay, next example, we have 2 sine x divided by 2 plus cos x. Now notice that we have a quotient, and anytime you're dividing two expressions, that's going to be the quotient rule. So same thing for the quotient rule. Our a is the numerator, which is 2 sine of x, and the derivative of sine is cosine, so a prime will be 2 cos x. The b value, b expression is 2 plus cosine of x, and the derivative of 2 is 0, so we can ignore that. And for cos x, the derivative is negative sine of x, so my b prime is negative sine x. Now I just plug it in. And the benefit of having all these terms here is now we just do substitution. So b is going to be 2 plus cos x times my a prime, which is 2 cos x, minus a, which is 2 sine of x, times my b prime, which is negative sine of x. And then we're going to divide that by b squared, which is 2 plus cosine of x squared. If I simplify that by distributing, I get 2 cos x times 2, which is 4 cos x. 2 cos x times cos x, that's a 2 cosine squared of x. And then you have negative times a negative is positive 2, and sine times sine is sine squared of x. All right, now here's where we have to be a little bit careful. Notice that these two terms, they both have a common factor of 2. And anytime you see a cosine squared of x plus sine squared of x, you should go a little bit further, because remember, our identity is that sine squared plus cos squared is equal to 1. So from this step, we're going to factor out the 2, because once again, we have a common factor of 2. So if you factor that out, that's going to leave us with cos squared x plus sine squared of x. And that's an identity that equals to 1. So we're going to replace that whole identity with 1. So we have 4 cos x plus 2 divided by 2 plus cos x to the second power, and that'll be our f prime of x. And then it says find f prime of 5. So again, like in Desmos or in a calculator, just replace each of the x's with 5, and you will get 0.6011 as your answer. Next up, we have 3x squared tan x divided by secant of x. Now here is where it might be beneficial to simplify first. So hint is, whenever possible, simplify first. Anytime you have tangent or secant as part of other trigonometric expressions, it's almost always easier to simplify first. So here's what we know. We're going to separate the 3x squared with the trigonometric part, which is tan x over secant of x. And then we're going to replace tan x and secant of x with what they equal to. We know that tan x is sine over cosine. We know that secant of x is equal to 1 over cosine. We also know that you can't divide by a fraction, so instead we're going to multiply by the reciprocal of the fraction, which is cos x over 1. Okay, now the cos x's cancel out. Here the cos x's cancel out, and we're left with just simply a 3x squared times sine x. So that's a lot easier to simplify than our original term, which is why always simplify first. And now we have our a, which is 3x squared, a prime is 6x, our b is sine of x, and b prime is cos x. I substitute. I have my a times b prime, which is 3x squared times, I have my b times a prime, which is going to be sine of x times 6x, plus my a times b prime, which is 3x squared times cos x. So simplify first. And then f prime of 2, if you just plug it into any calculator, you'll get 5.9178. Okay, next we have f of x equals to 3x times sine x cos x. We want to find f prime of x and f prime of 4. So this one's a little complicated because we have a product of 3 terms and not just 2 terms. But for the product rule, we can only have 2 terms. So here's what we're going to do. We're going to call the first term 3x, we're going to call that a. And the second term sin x cos x, we're going to call that b. Okay? And it's going to get a little complicated because we're going to have a product rule within a product rule. So a is 3x and a prime is 3. So that's the easy part. Okay, we'll leave it at that. Now b is sin of x times cos x. So when we take b prime, we have to do the product rule again, because think of b as a separate function. Okay, don't think of b as part of this original one. B is a separate term, sin x cos x, but that's still a product rule because these 2 terms are being multiplied. So we have to do like a subproduct rule. So the first term we're going to call m, the second term we're going to call n. So according to the product rule, it's going to be n times m prime plus m times n prime. So my m is sin of x, my first term. Its derivative is going to be cos x. My n is going to be cos x. Its derivative is going to be negative sin of x. And for b prime, I have n times m prime, which is going to be cosine squared of x, times m, which is sin of x, times n prime, which is sin of x times negative sin of x. That's a negative sin squared of x. So that is my b prime. Okay, so now if I plug these in, the original function, the product rule is going to be b times a prime plus a times b prime. So if I plug everything in, my b is sin x cos x times a prime, which is 3, plus my a, which is 3x, times my b prime, which is cosine squared of x minus sine squared of x. And that's it. We can leave it like that. And then f prime of 4, if you plug it into any calculator, replace all the x's with 4, is going to be negative 0.2620. Okay, another one, we have 6 cos x plus 5 tan x. Now here, we do have a tan x and a cos x, but there's no product or quotient. So in that case, it's a lot easier when it's just adding and subtracting to take the derivative separately. So the derivative of cosine of x is going to be negative sine of x. The derivative of tan x is secant squared of x. These constants just come down. And then if I simplify this, we get negative 6 sine of x plus 5 secant squared of x. And then if I plug in negative pi over 3 for my x values, I'm going to get 25.1962. Now, one thing is when you plug it in, secant squared, you can't really plug that into a calculator. So unless you're using Desmos, I think you can, but on a normal calculator, you'll have to rewrite secant squared as 1 over cos squared of x. So this becomes 5 times 1 over cos squared of x, which is going to equal to 5 over cosine squared of x. So for adding and subtracting, when they're separate terms, we don't need to rewrite tan as sine over cosine. We can just take its derivative. Okay, now here we do have to simplify because we have a quotient. So anytime you have a product or a quotient, simplify first. So tan x is going to be sine of x over cosine of x, and then you have the minus 3, and you have over 1 over cos x. Remember, when you have a complex fraction, you multiply each term by the LCD, which in this case is just going to be cos x. So I multiply both the top and bottom by cos x. And then I distribute. So if I have cosine of x times sine x over cos x, then the cosine of x's will cancel out, and all I have is a sine of x. Cosine of x times negative 3 will be negative 3 cosine of x. And on the denominator, the cosine of x's will cancel out. So remember, when you have a complex fraction, so we have sine of x over cosine of x minus 3 over secant, which is 1 over cos x. So our denominators are cosine of x and 1 and cosine of x. So my LCD is just going to be cos x. So we learned before that we can multiply all the numerators by cos x. So this one, and this one, and this one. So then here the cosine of x's cross out. We're left with sine of x minus 3 cosine of x, and the denominator just is equal to 1, which we don't have to write. And now I can take the derivative. So the derivative of sine is cosine, and the derivative of cosine is negative sine of x, but we have a negative times a negative, which becomes a 3 sine of x. And that's it. Please come to class with questions.